bottom and the top are exactly the same. What do you think, Steve? 1, right? Because isn't 2 over 2 1 and 3 over 3 1 and 5 over 5 1? So square root of 2 over square root of 2 is really 1. All I'm doing is multiplying by 1. It's going to look a little different when I'm done, but it's still the same number. You can't do whatever you want to do. What is 1 times the square root of 2? Well, it's the square root of 2. I just have 1. The square root of 2 times the square root of 2 is the square root of 4, which is, and if I do it right, these two should multiply together to just become the number that was underneath the wrap. And I leave it that way, square root of 2 over 2. It's okay to have a square root on top, you just can't have one in the bottom. We have a fancy term for this. This is called rationalize the denominator. Rationalize the denominator. It sounds kind of fancy, but it just means we don't want the bottom to be an irrational number. We want it to be a whole number, and it's easy to do. We just multiply by whatever's down on the bottom, top corner. So let's say I had this, 2 over the square root of 6. I'm going to multiply the top and the bottom by what's down on the bottom. So we're going to go square root of 6. Square root over square root of 6. So whatever's down here, we just use it flat. When you multiply straight across, you take 2 times the square root of 6. The 2 is outside the radical. It's free. It's not in jail. It's free. It does not want to go back. So it stays on the outside. You go 2 square root of 6. The 2 is what we call a free bird. It is not going back to jail. It stays outside. The 6 is in jail. It can't get out because it's not perfect. They got to stay in their respective spots. On the bottom, we take 6 square root of 6 times square root of 6, get the square root of 36, which is 6. Now here's my question.
Oh my God. And your third leg is really, it's even bigger.